Okay, everybody, one last set of examples here to help us out. We do need to define the term factor completely. Because when you see that statement, factor completely, it means that in addition to our normal factoring, we have to attempt to do one other thing. That is to look for any greatest common factor amongst all of the terms before factoring in the remaining polynomials. So let's talk about this first one. It says factor completely 3x squared minus 6x minus 72. And one thing should occur to you right away, that each of the coefficients shown are divisible by 3. See it? Well, you may not see it right away, but if you consider this as being something like 3x squared minus 3 times 2x. Let's see, 72. What divides into 72? Well, 3 would go into 72. Well, I kind of have to do this out to the side myself. 3 goes into 72. 3 into 7 goes in twice, giving me 6. Subtract the 6, that gives me 1 and 2. I know that 3 goes into 12 4 times, and yeah, sure enough, that's nice and even. So we know that it's 3 times 24. So we should factor out a common factor of 3 before we start anything else. So let's go ahead and do that. I'm going to factor out 3. So this is actually equal to 3 times the quantity x squared minus 2x minus 24. And it simplifies our problem a bit because now we don't have to try and find two factors of 72 and factors of 3. All we really have to do is find two factors of 24, negative 24, whose sum is negative 2. So we think a bit on that one, and we might note that we know that 24, negative 24, is exactly the same thing as negative 6 times positive 4. So, and of course, that's supposed to be a 4 right there. 4. And we know that negative 6 added to 4 gives us negative 2. And so when we add those together, of course, that's going to give us our middle term. So we factor this as 3 times the factors x minus 6 and x plus 4. And this is the complete factorization. So the real trick right here is just remembering that if we're going to factor something like this particular trinomial, we should always aim to factor completely by removing any common factors. So let's look at the second one. What's the common factor? Well, sure enough, it's 5, right? So we think about 5 coming out, and what does that leave us? X squared minus 5 times what gives us 10? That's right, it's 2 times xy minus, let's see, 15, that would be 3y squared. All right, so this is kind of similar to one that we did before. We know that we're going to end up with two binomials in x and y. So we're going to have x and y in one factorization, x and y in another factorization. And let's see, we need two factors of negative 3 whose sum is negative 2. Well, that should be an easy one. We know that negative 3 added to positive 1 would give us our factorization. So there it is. 5 times x minus 3y times x plus 1y is our complete factorization. All right, one more. What's our common factor among 3a squared b, 18ab, and 81b? Spot it yet? Well, definitely 3, right? 3 goes into all of those coefficients. And how about that b, right? That's in each of them too. What happens when we factor it out? Oh, let's see. 3b times a squared gives us our first term. 3b times 6a gives us our second term. And let's see, 3 times what gives us 81? 3 times 3 into 81. 3 into 81, 3 goes into 8 twice, gives us 6. Subtract that, gives us 2. Bring down the 1 7 times, which, that's even, right? So minus 27. All right, so let's see. We need two factors of 27, negative 27, whose sum is negative 6. Well, I know that negative 27 happens to factor as negative 9 times positive 3. And when you add negative 9 and positive 3, you do get negative 6. Positive 3 gives us negative 6. So our factorization, 3b times a minus 9, right, which is one of our factors here, times a plus 3, which was our other factor here, gives us our complete factorization. And we're done. Good luck with the homework.